Okay, so in this lesson, we're going to look at evaluating functions where a set of ordered pairs are given. So notice that this function f has 1, 2, 3, 4, 5. It has 5 ordered pairs. So it's a finite set of ordered pairs. And what you want to do is you want to use this set of ordered pairs to find each of the following. All right, so it's not a difficult concept. It's fairly easy to determine. So remember, in number 1, you want to find f of negative 6. Remember, f is your function name. So here's your function f right here. So remember, f consists of these ordered pairs. And so remember what f of negative 6 means. So basically, remember this, f of negative 6 means what is the y value? What is the y value when x equals negative 6. So remember, this is f of x. So x here, I'll go ahead and write it like this. This is f of x. So x here is negative 6. So you want to find what's the y value when x is negative 6. All right. So if I go to my function, I've got to look for the ordered pair where x is negative 6. So this is the one where x is negative 6. So that y value is negative 1. So the answer is negative 1. All right, it's that simple. It's not difficult at all. So number 2, now this time, now make sure you read this correctly. This says 2 times f of 8. So we got to find f of 8 first. So remember, f of 8 means what's the y value when x is 8. So I got to find where x is 8. So x is 8 here. That y value is 2. So this becomes 2 times 2, because remember, f of 8 is 2, which is 4. So the answer is 4. Okay? Over here, so let me go ahead and just write it right here. So this is letter C. So letter C says negative 3 times f of negative 8. So we got to find this first. So remember, we got to go to function f. So here's my function f, which consists of these 5 ordered pairs. And so f of negative 8 means, just like this one, what's the y value when x is negative 8? So when x is negative 8, this is the ordered pair here. See, x is negative 8, that y value is 4. So this becomes negative 3 times 4, which is negative 12. Okay, so the answer here is negative 12. So remember, it's negative 3 times 4, which is negative 12. Okay, and then do the same thing with the rest. Now notice that this operation here is addition, this is subtraction. Now this one consists of subtraction and multiplication, so keep that in mind. So let's look at this one. So f of 8, remember, what's the y value when x is 8? So that's 2, right? So this becomes 2 plus, and then f of 2, what's the y value when x is 2? So when x is 2, the y value is 0. 2 plus 0 is 2. So the answer is 2. Here, f of negative 3. So what's the y value when x is negative 3? So here's where x is negative 3. That y value is 2. So I get 2 subtract, and then f of negative 8. So f of negative 8, what's the y value when x is negative 8? That is 4. And 2 subtract 4 is a negative 2. All right. In f, you want to find f of 8, subtract 2 times f of negative 6. I'm going to go ahead and put that below it. So f of 8, so what's the y value when x is 8? So x is 8, y is 2, so that's 2. Subtract 2 times, and then f of negative 6, what's the y value when x is negative 6? The y value is negative 1. Now be careful here. So remember, this as you read it, says 2 subtract 2 times negative 1, right? Which means the same thing as 2 plus the opposite of 2 times negative 1. So what I'm saying is that this means the same thing as 2 times negative 2 times negative 1, right? Negative 2 times negative 1. I'm sorry, I did not mean 2 times, I meant 2 plus. Because remember, we're changing subtraction to addition. So 2 plus negative 2 times negative 1. Negative 2 times negative 1 is 2, so 2 plus 2 is 4. Okay, so that was number 1. So it's not difficult at all. It's a very, very simple idea. So number 2, let's do one more. Number 2, same thing. You're given this function g this time, and function g has also is a set of 5 ordered pairs, and it doesn't have to be 5. It just so happens in these 2 examples I chose 5. But you do the same thing. So what's the y value when x is negative 7? So I go to my function g, and I find where x is negative 7, the y value is negative 3. Very simple. Over here, let me go ahead and put that here. So this says g of 6 divided by 2. So I got to find that numerator first. So g of 6 is, let's see, what's the y value when x is 6? Here's where x is 6. That y value is negative 8. So I take negative 8 divided by 2, because that's what that says. Negative 8 divided by 2 is a negative 4. Okay, over here, this says 1/6 times g of negative 7. So let me go ahead and put that here. So 1/6 times, now g of negative 7, I go to my function g, and I find where x is negative 7. So g of negative 7 is going to be negative 3. So I get 1/6 times negative 3, which is negative 3/6, right? Reduce it, make sure you reduce, which is negative 1/2, and leave it as a fraction. Don't write as a decimal, just in case it doesn't terminate. So never approximate, always give the exact answer. So we get negative 1/2. All right, so very simple, not difficult at all. All right, so g of 0 plus 1/2 times g of 6. So g of 0, that's easy. When x is 0, y value is negative 2. And negative 2 plus 1/2 times, and then g of 6 is negative 8. So this becomes negative 2 plus 1/2 of negative 8. 1/2 times negative 8 is a negative 4. A negative 2 plus a negative 4 is a negative 6. All right, very simple, not difficult at all. This says negative 5 times g of negative 2. So that's negative 5 times. Now we got to find what g of negative 2 is. So when x is negative 2, the y value is 5. So negative 5 times 5 is a negative 25. All right, over here, and we could put that under here. So we got to find g of negative 2, whatever that is, we divide by 3, and then we subtract g of 2. So let's find g of negative 2. So what's the y value when x is negative 2? So when x is negative 2, that y value is 5, right? So this becomes 5 divided by 3 minus g of 2, and g of 2 is 1. All right, so 5/3 minus 1. All right, and so then you just add those two fractions. So let's go ahead and find the LCD. So remember, this becomes 5/3 minus 1 over 1, right? So the LCD is 3. So I'm going to write two fractions with 3 as a denominator. So 5/3 is equivalent to itself. See, the denominators are the same, so the numerators have to be the same. Now over here, 1 is equivalent to what number divided by 3? Well, you know that it's 3 divided by 3, right? So to go from 1 to 3, I'm going to have to multiply the denominator by 3. What I do to the denominator, I do to the numerator. 1 times 3, 1 times 3, so you get 3 divided by 3. 5/3 minus 3/3 is 2/3. Okay? Again, do not write this as a decimal because, first of all, this does not terminate, right? 2/3 is not a terminating decimal like negative 1/2 is. Negative 1/2 is negative 0.5, 0.5. So leave it as a fraction. So the answer is 2/3. Right? And that's it. So that was a very simple concept. So that's how you're going to evaluate functions where the ordered pairs, where a finite set of ordered pairs is given. All right, so that's the end of this lesson.